Okay, today we're going to be talking about matrix operations and what a matrix is and matrices. Matrix is a rectangular. Oh, I need to have my right thing here. So it's a rectangular arrangement of numbers in rows and columns. Numbers. We do rows and columns. And matrices, you see these a lot in like your computer science stuff. So here's kind of like what a matrix looks like here. It's just, instead of like dealing with like one number at a time, you're dealing with, six numbers right there. And we got like rows and columns, and they have the different spots and everything. So another word here, the dimensions of a matrix with n rows and n columns is this right here. So n by n, and it's read n by n right there. So like for an example down here, it's always rows by columns here. So if you look, let me select it here. You have 2 rows, and then you have 3 columns. So you would say that the dimensions of this right here would be 2 rows by 3 columns. So it's a 2 by 3 matrix. Usually I'm going to say 2 by 3, 10 by 10, 12 by 7 or something like that. Those are your different dimensions here. Now, as far as the individual pieces of the matrix, we call those elements. So each, number here, 4, -1, 5, 0, 6, 3, those are each individually elements. Now, as far as labeling this matrix here, we say it's matrix A. We're going to put a big capital A, and then we'll call it subscript right here. We're going to say it's a subscript of 2 by 3 right there. So that's literally saying that's matrix A, which is a 2 by 3 matrix. Okay, so just like addition, with I guess integers, you can do addition and subtraction with matrices as well. Now they have to have the same exact dimensions. If they don't have the same exact dimensions, you cannot add or subtract them because you're going to have stuff that doesn't line up. Like for example, on this next page, we're going to have a 1 by 3 matrix and then a what is that, a 3 by 1 matrix right there. And since those aren't the same dimensions, you wouldn't have like the pieces to line up. So they have to have the same dimension. So adding, subtracting, super easy. So you're going to go top left with top left right there. 2 plus -3 is -1. Okay, and that's going to go in the new top left of your matrix. All right, you got 4 and 2 right there. Add those. That'll get you 6. You got 0 and 4 in the bottom left. That'll get you 4. And then 1 plus 0 on the bottom right. That'll be 1 right there. And that's your new result matrix right there. Now be careful when you have subtraction. So subtraction, you got to go 4 and then -2 right there. And what some people will do is they'll just kind of think about it in their head. You could, if you want, change this plus or change that to a plus and then go change all of your signs inside to negative, negative, positive, negative, positive, negative. So it's kind of like you're distributing the negative right there. So if that helps you out there with subtraction, I would encourage that. Make sure you are adding the dimensions correctly here. So you got 3 rows and 2 columns going on there. So these are both 2 by 3s. In fact, they might even ask, nope, they're just asking for the operations there. So, okay, 4 plus -2 or 4 minus 2, if you kept it the same, that should be 2 regardless. You got 6 and -3, so that was 3. You got -2, and then it was minus -4, so that changed it to a plus. So that's +4, so that should get us 2 again. And then you got 2, basically -2 right there, I got us 0. You got 1, and then it was minus -3, so it was 1 plus 3, that should have been 4. And then 5, and then -1 was also 4 right there. So that's a new 2 by 3 matrix. Okay, so that's pretty straightforward. Most people don't really struggle with that, except, just maybe little mental errors there, so be careful. Now, sometimes they'll give us equations here. So that means if two matrices are equal, that means each element should be equal to the corresponding element. So the 2x right here should equal 5, which I guess that means x is 5 halves, or 2.5. And then we can say, I guess for this next one here, 3 is equal to 3y. Okay, so then divide both sides by 3. Obviously y is equal to 1. And then, I guess for this last one here, you got 3z, that element equals that last element, 9 right there. So that'd be divided by 3, and z equals regular 3 right there. So sometimes they'll give you actual equations, and then you'll got to figure out which one goes with what. Okay. Now, kind of the hardest type of an example is when you have something like this here. So you have this top left element equals that right there. So 2x plus y equals 6, which you can't really do much with. But then when they write this, x minus 3y equals 31, if we write that as well, well, that's an elimination or a substitution type of problem there. So we can use elimination, substitution, doesn't matter which one here. So I guess I'm going to go ahead and use elimination here, and I'm going to multiply this first equation here. If I do 3, I can cancel out the y's. So that's what I'm going to do there. So we'll go 6x, what's that, plus 3y, and then equals 18, I believe. The y's should cancel out. Looks like you have 7x, and then 31 and 18, I think that's 49. Oh, good, that's going to come out real clean there. So divide by 7, and that's x equals 7. Okay, and now that we have that, we can go plug it back in to go find, I guess, our y value. And I'm going to do that first equation, or the second. Well, actually, they're both about the same. First is good here. So 2x was 7. Or, I'm sorry, no, 2x was y. 2x plus y equals 6. This thing's not right in here. Okay, so that's 2 times 7 plus your y value equals 6. So that's 14 plus y equals 6. And then we're going to subtract 14 from both sides. And that gets us, I guess, y equals negative 8. And then, if you want to write it as an ordered pair, you can. I don't know if it necessarily matters on this one here. If you do, because we're not really talking about, equations of lines and stuff like that. So I think it just individually we get there. So sometimes they'll give you ones that look like that there. So now going back here to kind of what I said earlier here, you cannot add these two right here. They're different dimensions. So can't add. The reason being, this, you always go rows by columns. It's got 1 row and 3 columns. As far as remembering which one's a row and a column, columns are always like going up and down. So, if you think about like structures, we say like, something that has columns, those are always going up and down. So this right here has 1 column, but it has 3 individual rows. So we'll say that this is a 3 by 1. Same exact thing here for F right here. Yes, they're both like kind of horizontal. They both have, I guess, 1 row, but one has 3 columns and one has 2. So this is like a 1 by 3, and then this is a 1 by 2. So once again, can't add these. Okay. Now sometimes you'll see what we call scalar multiplications when solving matrices, or sometimes you're just doing operations here. So if you have like a number outside of a matrix here, it works exactly how you would think. A lot of people think distributive property, except you're doing multiple distributes. So k times a, k times b, k times c, times d, e, and f. So just multiplying through there. Pretty straightforward. So let's see what that looks like here on this one here. So you got just a lot going on, just a lot of mental math here, usually with these. 4 times 3, that's 12. 4 times negative 2, that's negative 8. 4 times 0, anything times 0 is 0. 4 times 3 is 12. 4 times 1 is 4. And then 4 times 6, 24. Now there is some of this that you can actually do using calculators. Most of the times it takes more time to type it out in the calculator, so I'm not going to worry about that today. But I think probably in the next video or two, I'll show you a couple things you can do with the calculators and the matrices. So kind of be looking out for that. Now, if you got something like this right here, we do have multiplication, and then we do have addition here. So they write out PEMDAS here to kind of remind us the order of operations. Usually do things with parentheses, which we don't have. After that, you do exponents, which we don't have. Then you do multiplication, division from left to right, which we do have some multiplication. And then we're going to do addition, subtraction afterwards. So basically distribute first and then add your two matrices. So negative 3 times negative 1 for the top left element right there, that would be positive 3. Negative 3 times 5 is going to be negative 15. Negative 3 times 4 is going to be negative 12. And then negative 3 times 0 is 0. And then now we're going to add those to the elements of the second matrix that we had there. Alright, 3 and negative 2 is going to be positive 1. Negative 15 and 1, that'll be negative 14. Negative 12, 5, that'll be negative 7 we had. And then 0, negative 3 will be negative 3. And that is it. That's your matrix. So, nice and easy there. Nothing too wild here. Now, every now and then you'll get these crazy equations that have a lot going on. This works real similar to like kind of what we did up here, except we got, a bunch of equations here. You got some distributive property here. Notice that there are parentheses around this matrix here. So we do need to distribute the 2 to everything. So I'm going to go ahead and do that. I mean, it's a lot going on here, but so what would that be? 4x minus 6 for the first matrix. All right, you got 10 and negative 2y. Now you got to do 2 to all this other stuff here too, because of the parentheses around it. So let's see here. That'll be negative 2, 8, 6, and 10. And apparently all that equals this other matrix that we have over here. So instead of going through and combining these two matrices here, since we have all these variables here, really we're trying to figure out what x is here. So you have the 4x right there. You got the negative 2. So if we add 4x and negative 2, whatever it is, it should get us 10. So that's actually enough information right there to get us an equation. We can go 4x minus 2 equals 10. And then we can go and add 2 to both sides. That should get us 12. And then divide by 4. That should get us x equals 3. Now you can do that with all the other elements here, but if you look here, some of them we don't really need to worry about here, because like you got, for example, negative 6 plus 8 does equal 2, and there's nothing to really solve for there. I mean, we can check and make sure we're doing everything correctly there, but that doesn't really solve us for y. So what I'm going to do now is go look at this negative 2y, make sure you get the negative with it, plus 10, apparently that equals 14. Color code this here. So negative 2y plus 10 equals 14. And I guess we need to subtract the 10 from both sides. That'll get us positive 4, and then divide by negative 2. That'll get us y is equal to negative 2. Those are your two x and y values right there. So that's a possibility for solving a matrix equation there. That's kind of what it looks like there. Into my space over here. Now every now and then they'll put, instead of like a regular x, we'll put like a capital looking x right here, and this usually means we're solving for a matrix. I guess matrix x. That's what this is asking for here. Solve for the matrix x. What matrix do I need to subtract to get this matrix right here? And there's a couple different ways you can think about it. The way I like to think about it here, I guess, I mean, yeah, there are many different ways here. I like to think about it like an equation here. So like what I'm going to do here is I'm going to subtract this entire matrix from both sides. I'm going to go, minus this entire matrix. Whoops, there should have been 6 there. So I have to do that same thing to both sides there. I'm going to subtract 2, 4, 3, 6. So if I go and do that here, I'm going to put the result down here on the left side. Stylus is struggling here today. So if you go 5 minus 2 right there, that should get us 3. If you go 2 minus 4, that should get us negative 2. If you do 3 minus 3, it'll actually get us 0. And then negative 4 minus negative 6 minus a negative, or actually no, negative 4, I'm sorry, just minus 6, that should be negative 10 there. My bad. Okay, and then that apparently equals this other matrix here, negative x here. Now, since we have a negative outside, we can multiply or divide both sides by negative 1, which is what we're going to do here. We haven't really gotten into it. Dividing with matrices, you got to be kind of careful with, so I'm going to say multiply by negative 1. So that'll get us negative 3, positive 2, 0, and then 10. And that should be that last matrix there. That should be matrix X right there. That's how you do that. Now, a couple other people will just maybe use some mental math. Oh, I need to do 2 minus something. That gives me 5 right here. So if you go 2 minus negative 3, that does get you 5. That's, I guess, a way to also check your answers if you would like to do that. But there you go. That is it right there. Operations with some matrices, basic stuff. And I think that, that is it here for our lesson.